Problems E2 looks difficult when you first look at it, but it's not as bad as it looks. We have a 62.8 kilogram box on a ramp inclined to 32.8 degrees. The coefficient of friction is 0.327. We want to know the final speed of the box if the ramp is 15.9 meters long. So the picture looks like this, and of course we know that our V initial up at the top is going to be 0, and we're looking for what is the V final down here at the bottom. So you're saying to yourself, hey, didn't we do a practice problem like this on Friday? And the answer, of course, is yes, we did. So we used the Vf squared equals Vi squared plus 2AD formula. And again, since the Vi is 0, this is going to go away. And to get rid of the square, we want to square root it. So my answer is going to be the square root of 2 times my unknown A times the distance of 15.9. So all we have to do is find the A. So that's it. It's going to be really, really simple. All we got to do is find A. Now, of course, some of you remember that finding A was a little bit more challenging. Well, I'm going to show you a little bit of a shortcut. If you remember, we said that A was equal to the net force over the mass. And we knew the net force in this situation was, of course, up here we had the F parallel was trying to pull us down, and if the motion is going to be downward, then friction, of course, is trying to pull the other way. And so the two forces that are fighting in F net are going to be the parallel force minus the friction force. If that's a positive number, we're going to accelerate. If it's a negative number, we're stuck there. And of course, this is still over m. But we know that F parallel is just equal to mg sine theta. And we know Ff is just equal to mu mg cosine theta. And of course, all this is still over m. Well, those of you who are wonderful at math know that we can factor out the m here, and then the m's will end up canceling out, leaving us the all-important handy-dandy equation that A is equal to g sine theta minus mu g cosine theta. So this formula will work anytime I am just sliding down a ramp and the only force pulling me is that parallel portion of my weight, which is the case here. So you say, hey, this is great. I don't even need to know the mass of that block up on top. So you're right. This piece of information is absolutely superfluous. The rest of it we, of course, need to know. So we know our mu is 0.327. We know the ramp is 32.8. That's all we need to know to be able to plug into here. Of course, we know that G is 9.81. Then we're going to take that times the sine of the angle, which we said was 32.8, minus the mu, which was 0.327, times G again, 9.81, this time times the cosine of 32.8. Now, what you want to do is just make sure you plug that in to your calculator all in one big step. It looks just like that. And if you plug that in properly, of course, you get 2.6, what would that be, 8, if we round that off correctly, 2.68 meters per second squared. So this was our missing acceleration that we're going to shove in much, much higher. So the 2.68 is what we were missing up here. So again, we just need to multiply that times our 15.9 and times our 2, and then square root that whole puppy. And we're going to end up with a final velocity of 9.12 meters per second. How easy was that?